several sounds. Okay, next. This is content. First of all, I'm going to explain the marine resources and the natural product, and then natural product research from marine invertebrates. In this slide, I'm going to explain the importance of natural product research. Actually, the natural product is almost same meanings with the secondary metabolite. Natural products are naturally occurring organic compound in organism, and although these are not essential for normal growth and the development of product of organism, but the natural products are invaluable platform of available or developing drugs like penicillin, taxols, and amphotericins. As you know, all of these compounds are from natural resources. Marine is also good resources for natural product research. We can, as you can see, we can find a lot of potential drug derived from marine organisms. Next, one of these compounds, yondalis, is already developed anti-cancer drug. The chemical compositions of yondalis was first isolated from extract of sea squid, one of the natural invertebrates. The other compounds are also in developing process. One of these compounds are already developed in the cosmetic compound. In this slide, you can see a lot of toxins from marine resources. As you know, the tetrodotoxin is one of the most poisonous material in nature. It was produced by pufferfishes. And the other such toxin, oxalic acid, and the bravotoxin is also famous toxin in nature. I would like to say again, marine is good resources for natural product research. From now, I'm going to explain my research. It is very important to collect marine organism from various marine environments for the study of good natural product research. Naturally, we collect and study the marine organism of the coast of Korean Peninsula. And we can conduct research on tropical marine organism in the Southwest Pacific through the Overseas Research Branch in Coast. The Overseas Research Branch in Coast was established in the state of the Chuuk, Micronesia in 2000. During last 20 years, we can visit, we can collect, we can study in tropical marine organism through the stations. And also, through the international collaboration research with the University of Philippines, we are able to access the Philippine marine organism. In this slide, you can see the site, the last site in Korean, Micronesians, and Philippines. And also you can see the various marine invertebrates. This was collected in three areas. In this slide, you can see our activities and the marine invertebrates, which are collected in Micronesia. During last 10 years, we did a lot of jobs in the kinds of collections and isolations and the next process. These photos are taken in Philippines. And also you can see the marine invertebrate in the right side of the slide. There are a lot of invertebrates including the sponges and the tunicators and so on. And in the left side, you can see a lot of persons, Filipino research teams and the Korean KIOST research teams. We collected marine invertebrates by the joint research team between KIOST and the UPB, University of Philippine Visayas. Yeah, and in this slide, the slide is confusing, but probably a chemist can understand of this meaning. I believe that, I hope that you can understood these meanings. Tropical sponge Hiltios, the Hiltios was shown in uplight. Hiltios was selected among Philippine organisms for the study of marine natural product. The sponge Hiltios was collected by hand scuba in 2016 along the shore of the Bohol Island. That is very, very famous island in Philippines. The sponge was extracted with organic solvent, and the extract was partitioned between butanol and the waters to remove the salt and the water-soluble component. Actually, by this process, the salt and the water-soluble materials are removed from extract. The organic compounds remain in butanol layer. The butanol layer was repartitioned with the aqueous methanol and the normal hexane. Through this process, lots of potash was removed from extract, and then the aqueous methanol layer was separated by reverse phase flash chromatography. From 8 fractions, the methanol layer was contained a lot of organic material. That fraction, the fraction was separated by HPLC, and then we can get the 9 material. The structure was drawn in here. In this slide, you can see the spectrum, NMR spectrums of compounds. Analysis of this NMR spectrum, we can draw the organic structures. And for the time saving, I cannot explain the details, structural elucidations. Anyway, this it is called the Scalarian type cestatopian. The Scalarian type cestatopian exhibit extremely spectrums of bioactivities, including anti-cancer, antibacterial, anti-inflammatories, and anti-fouling activities. According to our research, these Scalarian analogs are displayed weak activities against the 3 gram-positive bacteria. And also from Hiltios, the same sponges just before I explained, in polar fractions, just before I explained the methanol fraction, in polar fractions, we can isolate the several alkaloids. This the number 10 and the number 14 is actually new compound. New compounds means not reported already. This is isolated for the first time by ourselves. And then the structure was elucidated by the same method, and the next one is also a kind of NMR spectrums. Using this NMR instrument, we can elucidate the structures. Next, by this similar process, we can try to isolate it from Sexospongia. This one is also collected in Bohol in 2018 from these sponges, we can isolate the 9 Helena-Quinault derivatives. And also the structure was elucidated by the same method, NMR spectrums, and extended the NMR spectrum NMR experiment. The previous explained compounds are tested bioactivity. I'm going to explain briefly the sulfase A and the ICL inhibitors. Sulfase A is very important for the development of antibacterial compound. Sulfase is a very critical enzyme to develop of bacteria. If we can inhibit the sulfase A inhibition activity, that means a new drug for antibacterial functions. The next, the ICL is also very important enzyme for the development of bacteria. ICL, isocitrate lyase inhibitor, means also antimicrobial drug. So we can try to test the sulfase and isocitrate lyase activity using our isolated compound. And these compounds previously explained that was isolated from terpene sponges. The list is like this. The result was displayed in the low level. Some of the compounds have more active than standard. In the right side, tripacil have 13 microgram per ml activity. Some of them are more active than standard. These things are prepared. These things will be prepared by papers, international journal, that will be published in a few days, in next month, I hope. And then these compounds, Helena-Quinault derivatives, are also highly activities and isocitrate inhibitor activities. That was very interesting to us. And also we tried to isolate it from our compound from Korean organism. The Scala spongia is also collected in East Sea of Korea, and the shape is like this. From this, we can isolate the similar alkaloid compound.
Excuse me, Dr. Ihesang, I think 1 more minute.
Okay.
Thank you.
This one is another example. By this way, we can isolate the various compounds and shallow waters, both Korean and tropical waters. And various compounds, the structure was defined by chemical investigations, and all of these compounds have various bioactivities, such as antimicrobial, cytotoxicity, enzyme inhibitor activities. We will do our job like this. We want to expand our research field by international collaborations and other research fields. Our job was done by our CHEST members, and biochemistry and taxonomy was assisted by the other collaborators in outside. Thank you.
Okay, thank you for your interesting presentation. Dear participant, if you have any question, you could please write in the chat box, or you can use the raise hand button so I can deliver the question to the presenter. Please. Okay, in your scenario, I think what the marine invertebrates that found in Indonesia that is could extract the natural product from it. I see in your presentation, the marine invertebrates is found in Korea, but when it's found in Indonesia, is it the same or it has to be different? Thank you.
Yeah, that is very great questions. Actually, almost 10 years ago, I want to try to make some research connection with Indonesia. Probably the university name is Diponegoro University. I met the research teams in Diponegoro University, and we started the international collaborations, but we cannot get permissions from the Indonesian government. You know, the overseas organism research is very difficult. Without permissions of government, we cannot do anything. It is very well known to natural product chemist. Indonesian marine organism is the best in the world. You know, probably a lot of scientists want to access Indonesian marine organism, but the process to get the permission from government is not easy. If possible, I want to access the area, and with the collaboration network. Actually, one of the graduate students from Indonesia will be joined my laboratory next year. Probably he can help to us, hopefully. Thank you.
Okay, thank you. A question from Pak Kennedy Sembiring. Is there any significant difference of chemical compound of marine organism, especially at invertebrate in tropical water and subtropical waters?
That is not easy to directly. Probably all job was I don't know more. I don't know exact information about this yet. We are waiting the further research in that issues. Probably next year I can say exact answer.
Okay, thank you. One question I think. How do the isolation extraction of marine invertebrates? How do you conduct sampling and keep the sample in good condition till it comes to the lab?
Sorry, I can't understand what you mean.
Okay, I repeat. How you do the isolation extraction of marine invertebrates? How do you conduct sampling and keep the sample in good condition till it comes to the lab?
With the help of good divers in Korean and Indonesian, we can collect the marine organism, and then there was frozen dry ice or ice makers, and then that was transferred to the laboratory with safe. The process was a very hard job. With the help of local persons, we can do that process. Actually, the collections and the deliveries of marine organisms in the overseas area was not easy. With the help of a local area, we can do the job safely. In the future, I hope in the future we made some connections with Indonesian scientists, can help each other, and also every the value will be shared. And you know, when we publish the paper, when you get the patent, our job was shared. All the light we shared. For example, several months ago, we got a patent from the result of Philippines organism. The oceans and the light was shared like this. I believe that probably you also understood of Nagoya protocols. That is very serious. I understand. Is it enough to you?
Okay, thank you. And I have to say thank you for Dr. Ihesham for great presentation and responses. And maybe we have to move to the second speaker, I think. We invite Dr. Fajar Yudi Prabawa, MTDes. Have you attend in this room?
Yes, Mr. Moderator, thank you.
Okay. And now we invite Dr. Fajar Yudi Prabawa to deliver the presentation titled Design of a Prototype Model for an Energy Efficient and Environmentally Friendly Salt Production House with the function of increasing the quantity and quality of industrial salt. The time is yours.
Thank you, Mr. Yuni, moderator. But I cannot share my file.
I see. Please, Dr. Ihesham, to turn off the share screen, I think. So stop the share screen. Thank you. I'm sorry, I think Dr. Fajar, you haven't hit the mute button.
Oh, sorry. Yes.
Okay.
Thank you.
Thank you.
Could everybody hear my voice?
Yes, you can hear.
Okay, thank you. Well, this is the visual material to present the salt, and we can also test that different from the previous presentation, which was the molecular of biology, which is very tiny, but it is very enriched, this room. So the main idea of this paper or research is the problems existing, which is the lack of salt, national salt demand, that ironically exists in the Indonesia, country having more than 80,000 kilometers of coastal area. So this paper would like to present it, about the real existing problems, and then trying to analyze and to give some recommendation for a better result for the national industrial salt balance. For the present 2021, the industrial salt balance, we can see as the slide, the demands, the real demands is around 3 million tons of salt per year. But the supply, the local supply is very few, only 2% of the industrial salt. So from decades, this country have been importing the industrial salt. This year, we imported 4.6 million tons. So there is the addition of the number of the imported salt, industrial salt, because the demands, which is 3 million tons, would be added with the spare more. That's one. And then for solving this problem, the government trying to increase the absorption of the local salt. The local salt means the raw material, raw salt. So it is stated the national plan for long-term development from 2020 to 2024 for salt self-sufficient started at 2021 plan with a targeted local raw salt produced around 3 million tons, but it is failed now because natural condition, high rainfall. And then the other program of the government is to increase the production of the local salt. Same, still the raw local, with the two types of program. One is the extensification, means the expanding of the new ponds, new salt ponds. And the second is the intensification, which is the work of the processing of the raw salt, the existing raw salt, which are increasing production program and the upgrading raw salt quality program to industrial salt. And then what's the concrete or the real program of the intensification by development of the mini washer plants and distributed them to salt central region. And next is to support the big washer plant. And what is the program of the extensification? It is the opening of the land, new land for salt ponding, for salt farming. The location would be at the Flores, NTT, and Sumbawa, NTB. But between two choice, there is a better one compared to other. We can see if we choose the extensification choice to increase the production of the salt, we will need around 2,000 more hectares to transform to become pond. This means the ecological loss or disaster. And then we will need a longer duration to opening, to land clearing, to permits, and it is of course very high cost program. But still it is ineffective because this salt farming type will be obstacled by rainfall. So the question is, how will the alternative proper way to improve industrial salt production? Then this research aim to figure the best solution for improving the industrial salt production using green technological approach. The data collection with the earth observation, documentation, and interviews, the research conducted since 2018 to 2020 simultaneously. And then the analysis method, we used a quantitative descriptive, which means a numerical data research. And then using the method of ADDIE steps for developing the model. This is the ADDIE. ADDIE is comprised from the analysis, design, development, implementation, and evaluation. And this is the preliminary research. So we emphasize two steps of ADDIE that are analyze and design. This is the location at the Madura Island at the East Java province at the Pamekasan Regency. The Madura Island is famous as salt island. So the oldest production of the salt and the biggest production. This is the common basic salt farming. It's called traditional, how to yielding salt. It is very simple. First, the channeling the seawater to the concentration ponds, and while the volume of the seawater lasts to 60%, the farmer will flow the water to the next ponds for intense evaporation. And then the last stage is the crystallization on the table of salt. These are the existing salt farming methods in Indonesia. Number A is a traditional method. This is a method that's very dependent to the meteorological rainfall, sun ray, and everything. So it works, it's efficient only on effectively 3 months in a year. Then the people, salt farmer, have advanced with using the plastic roof in form of the tunnel. So they can produce salt every day in a year. Means they can produce more salt. Then the C, this is the picture of the farmers that use technological intervention by using a geo-isolator on the base of the ponds. This is very good for speeding up the production. And D is called prism salt house. The difference between prismatic and tunnel is prismatic is a closed house, and then the tunnel is open house. This is the comparison of the salt yield between those methods. So the traditional method yield 60 tons per hectare per year. The conventional method with geo-isolator use could earn double. And then the prism roof with a combination geo-isolator could earn 180 tons. There is the last technology that introduced 2018, the Japanese method, could produce 390 tons per year. This is a very advanced so far. And the minister of the research at that time assumed that the result of the Japanese method salt could be double or even triple with the combination of the salt house. It means 1,170 tons per year. This is the comparison of the total salt yield between Madura Island and total national. And we notice from the green blocks that the methods that are enough to supply the national demand are the prism closed house and the Japanese method, at least that. And from the result of this study analysis and compiling, we make some notice to mix the best practice and the success story of its methods to combine them and upgrading them into a new model or concept of modern salt production. We call it salt production house. So it is the combination of the success story and best practice of the closed house, prism method, the tunnel, and the Japanese method.
Excuse me, 1 minute left.
Thank you, Mr. Moderator. So the benefit of the all methods will be achieved by the SPH or salt production house. But we will speeding up and boosting up the result with the intervention of the more technological engineering as chemical and physical engineering for speeding up the process of evaporation, crystallization, and also for boosting up the result. So the conclusion is the number of salt yield, which are raw salt and industrial salt, could be improved in significant faster work, lower cost, and not giving impact to the environment by choosing the option intensification, not choosing the extensification of land ponds. Next, the development for this intensification option, the development of the program of development of the new washer machines, more washer machine upgrading parallel with upgrading the capacity of the washer machine and improving more raw salt yield on the existing floors as well. Production of industrial salt, it is needed to support the self-sufficient program. And the last one, the methods that recommended for this work are Japanese method that combined with salt house. And also this research recommendation, the SBA concept as well. Thank you very much.
Okay, thank you for your great presentation. Is there any question? I see no question. Actually, I have one question. In your design, is there
concept of SPH? We will introduce new intervention technology from physical and chemical as well. So especially to conditioning the brine, we will use two types of this technological engineering. For the physical engineering, we will use the thermal. So we will speeding up the duration of each stage of the salt production, especially at the evaporation stage, and also the high concentrated brine stage with the thermal. So we will use some kind like metal-based how to say metal-based compartment with the electricity to conditioning the thermal. So this will speed up the evaporation process. And then what's the chemical intervention? This will be used especially at the stage of the crystallization. We will use the chemical process to accelerate the process of separating the impurity in seawater. So the process will separate first. The function of this chemical process is to separate the impurity to the NaCl, to the salt. And the second is the chemical process will aggregate more faster the ionic NaNCl to boosting up the crystallization. I think that's the technological aspects.
Okay, thank you, Dr. Fajar Yuti. This is the great presentation, and thank you. Okay, I will move to the next speaker, Dominicus Yuli Wilson. Have you attended here in this room, Mr. Dominicus? I think he hasn't attended in this room. And we move to the next speaker, Mr. Agus Hirmawan. Have you attended in this room?
Yes, sir.
Okay, thank you. Maybe the technical operator can play the video. Excuse me, the technical operator.
Good morning, ladies and gentlemen. The Honorable
Technical
Judicators.
operator, please
My name
help us to
is
play the
Agus
video.
Hirmawan. I'm from Good morning, ladies and gentlemen.
Okay,
The Honorable Judicators.
panitia,
My
bisa
name is
minta
Agus
tolong untuk
Hirmawan.
diputar videonya,
I'm from
Rundi.
Indonesian Naval Postgraduate School. Today,
Or
I would like to
Mr.
deliver
Agus
my
Hirmawan,
oral
I'm sorry, I
presentation
think, have you
entitled
prepared the material already?
Comparison Study of Various Tidal Prediction Models with Water Elevation Data
Yes, maybe I can
in Benua Waters, Bali.
play.
Introduction.
Okay.
Ini sudah jalan nih
Indonesia
yang room D ini.
is
Okay, thank
one
you.
of the area that have the potential for various marine activities because of its strategic location. Tidal prediction aims to get the value of tidal water level elevation in the next few years. Pushidrosal used tidal data to correct bathymetric measurements and determine datum charts and tides on marine maps. This study was conducted to compare the TMD TPXO 7.2 oceanomatics, tide, and Mike 21 tidal prediction models to the water level elevation data in the Benua Bali waters to see the level of accuracy in its tidal prediction model. This research is trial on one type of public water, namely the type of by waters located in waters of Benua Bali. Observation data is data that comes from the BIG telemetry tidal station for a period of 1 year from January to December 2020. A comparison of the water level elevation graph between the observation data and its tidal prediction model is displayed to see the suitability of the graph form. The results of the comparison of the graphs are as follows. The comparison picture above shows that the same tidal chart pattern at several high and low tide points. It can be seen that there are differences in tidal height value. The comparison graph shows that the tidal observation data at several points higher than tidal prediction model data. The comparison of harmonic component values of the observation data and its prediction model is shown in the following figure. The picture above shows that comparison of amplitude and phase value of observation data, that tidal prediction model data. Comparison of amplitude and phase value shows a small average difference of constants. The difference in the value of the largest amplitude on the component K1 and M2. The largest phase difference in the M4 and MS4 component. The correlation value is used to measure the close correlation between two variables, namely observation data with each type prediction model. The correlation graph of water level elevation shows in that image below. The magnitude of the correlation value above indicates that there are strong positive correlation between the data, namely the observation data and the data for each tidal prediction model. The largest correlation value is now tide. Smallest is oceanomatics well with a value of 0.9227. The RMSA value is calculated using the Percival theorem, which is to calculate the average mean value or average absolute value of the deviation. From the table above, it can be seen that the smallest RMSA value or having a good level of accuracy is now tide with a value of 0.14 meters, while the large or poor accuracy is oceanomatic with an RMSA value of 0.23 meters. The result of calculation using the Formzal number so that the overall value is included in the Formzal value range, so that the tidal type is included in mixed tide type. Mixed mainly preferring semi-diurnal. Based on the Z0 value above, TMD shows that difference in the Z0 value is smaller than other tidal prediction models. The Z0 value is used for the tides on the Indonesian marine maps. Conclusion and suggestion. Conclusion. The best tide prediction model that can be used in bay water is based on comparison of all parameters, namely the now tide prediction model, then Mike 21, TMD, and oceanomatic. Suggestion. As a recommendation for future research that can be done are A. Comparing the now tide prediction model with other tide prediction models besides TMD, oceanomatic, and Mike 21. B. Comparing the now tide at the study site with different type of water such as inlands, straits, offshore, and others. C. Comparing other tidal processing software to obtain tidal harmonic component. I think that's all from me. Thank you for your attention. See you next time. Masih di Excuse me, moderator. You still yes.
I'm sorry. Okay, I'm sorry. Okay. Thank you for your presentation. I think it was a good presentation. Is there any question? Please just write in the chat box or just hit the raise hand button. Okay, well, we are waiting for the participant. I think I have one question to Mr. Agus Himawan. What parameter you use in your scenario, in your model to predict the tidal model?
Maybe I can answer in bahasa Indonesia.
Okay, it's no problem.
Yes. Parameter yang kita gunakan untuk perbandingan model dan data observasi atau data di lapangan adalah nilai RMSE dan nilai korelatif, di mana nilai RMSE terkecil atau error yang terkecil bisa menggambarkan kalau model ini nilai errornya lebih kecil sehingga dapat digunakan atau sebagai parameter untuk mengetahui model tersebut bagus atau lebih bagus daripada model yang lainnya. Jadi kita membandingkan data pasang surut, data di lapangan dan dengan data model, manakah model yang bagus yang dapat digunakan sebagai untuk alternatif mendapatkan data pasang surut secara praktis. Demikian, terima kasih.
Okay, thank you for your responses. Any question out there? Okay, if no, I would like to say thank you for Mr. Agus Himawan. And then we have to move to next speaker, Mr. Russell M. Tambunan. Have you attended here? Mr. Russell? I think he hasn't attended yet. Okay, we would like to invite the next speaker, if so. Mr. Yayan Saiful Marian, have you attended? Mr. Yayan Saiful Marian. Okay, I think he hasn't attended in this room either.
Excuse me, moderator.
Okay.
Mr. Russell and Mr. Yayan still sailing in Navy ship. You can play a video.
Okay. Okay, we can play the video, but I think the Q&A session, maybe you can write in the column chat, and later if they have joined in this meeting. Maybe I'll deliver the question. Okay. For Mr. Rosal M. Tambunan, we would like to invite him entitled Comparative Study of Determination of Vertical Datum for the Importance of Shipping Safety between Admiralty and Least Square Method in Indonesian Water. The time is yours.
It's an honor to be a presenter at the International Conference on Maritime Science and Advanced Technology MSAT 2021. As the first author from Hydrography undergraduate study program, Naval Technology College will present about comparative study on the determination of vertical datum between Admiralty and least square methods in 11 locations of Indonesian coastal waters. The varying meteorological factors of seas and tidal characteristics tends to significantly affect the topographic condition of land, seabed, and coastal waters in Indonesia. Tidal data plays an important role in determining and measuring the vertical contour framework and position of the Earth's surface. Tidal data processing aims to obtain the value of the harmonic constant, which is used to determine the tidal prediction, Z0, and chart datum as a vertical control, namely Admiralty and least square. These methods produce different values and quantities, which tends to affect the accuracy of determining the elevation of tidal prediction, Z0, and chart datum. Furthermore, each method needs to be verified by comparing them with the calculated tidal to compare each method's observation and prediction data. The aims of this research include comparing the accuracy of tidal prediction and observational data for the short period, 1 month, and the long period, 1 year, analyzing the accuracy of tidal prediction using the Admiralty and least square methods when implemented in various Indonesian waters with different characteristics. Analyze the most accurate method in determining Z0 and chart datum at each observation location. This image shows 11 BIG intertelemetry tidal stations locations in Indonesian waters. Tidal elevation observation data were obtained from observation locations with different water conditions, namely Sabang, Marina Ancol, Natuna, Subatik, Sendang Biru Malang, Makassar, Lembar, Mariteng NTT, Ternate, and Jayapura. The length of the tidal elevation observation data used is 1 year in the 2020 period at each observation location. The following theories are used in this research, ranging from tidal theory to verification of prediction data error rate. The data in this study use data on variation in sea level and at the observation location sourced from BIG telemetry tidal stations. Based on the harmonic data, which produced by those two harmonic processing methods, the following were calculated, such as Fromsdal index to determine the tidal type, Z0 predicting tidal elevation based on the harmonic constant in each method, verifying the error rate of the prediction data produced by the two methods by calculating the root mean square error. The process data is analyzed by comparing the Fromsdal index, Z0 value, and root mean square error to obtain the most effective methods for determining vertical datum. This table shows the calculation of the Formel index using the harmonic components constants produced by the Admiralty and least square methods in each observation data for 2020 period. In general, there is no significant difference in tidal type except in the waters of Natuna, Makassar, and Lembar. The result of the calculation of the Formel index using the least square harmonic component constant indicates a transition of mixed tide prevailing diurnal to mixed tide prevailing semi-diurnal or vice versa. Especially in the waters of Eastern Indonesia, the types of waters produced by both methods show the same results. This table shows the calculation of root mean square error to verify the error rate of the prediction data produced by the two methods. In general, the RMSA accuracy rate of the least square method is smaller than the Admiralty method in every observation location. The RMSA maximum and minimum range of the Admiralty method prediction data is greater than a least square at each observation location. The greater the number of harmonic components and the longer the observational data used in tidal data processing with least square method, the smaller the RMSA value obtained and the more accurate tidal prediction will be. Non-harmonic constant from the processing in the Admiralty method are used to determine the Z0 value with combination analysis. Determination of the LLWL is obtained by subtracting the MSL with the Z0. Meanwhile, in the least square, the lowest elevation of the prediction data is the LLWL, and the range of MSL value with the lowest elevation prediction data is the Z0 value. In general, out of 11 observation locations, 8 locations, namely Marina Ancol, Sendang Biru Malang, Subatik, Lembar, Maritime NTT, Ternate, and Jayapura Waters, have a maximum Z0 value obtained from processing 1 month observation data with the least square method. 2 locations, namely Sabang and Makassar Waters, have a maximum Z0 value from processing 1 month observation data with the Admiralty method. 1 location, Natuna Waters, has a maximum Z0 based on 1 year observation data with the least square method using a script of 90 harmonic components. Meanwhile, Z0 maximum minimum range using the least square method is greater than Admiralty. Conclusion of this research are the RMSA accuracy rate using the least square method is smaller than the Admiralty. Each observation location shows that the least square method has a much smaller RMSA than the Admiralty. The prolonged tidal observation data and the number of a harmonic component used in the least square method do not determine the Z0 value. In general, out of 11 observation locations, 8 locations, namely Marina Ancol, Sendang Biru Malang, Subatik, Lembar, Maritime NTT, Ternate, and Jayapura Waters, have a maximum Z0 value obtained from processing 1 month observation data with the least square method. 2 locations, namely Sabang and Makassar Waters, have a maximum Z0 value from processing 1 month observation data with the Admiralty method. 1 location, Natuna Waters, has a maximum Z0 based on 1 year observation data with the least square method using a script of 90 harmonic components. Based on research conducted at 11 observation locations that are considered to represent the characteristic of Indonesian waters, The use of determining the harmonic component constant of the Admiralty method is accurate when used to determine Z0 and chart datum in Indonesian waters and can support safe navigation at sea. The use of determining the constant of harmonic components with the least square method can be used as a comparison for the Admiralty method to determine Z0 and chart datum in Indonesian waters and accurately be used to predict tidal data in Indonesian waters. Continuous observation should be carried out at various different locations with a longer observation period. To analyze the method of determining the harmonic components used in determining Z0 and chart datum in Indonesian waters. Thank you for listening. May all those we have shared be beneficial for all of us.
Thank you for your interesting presentation. I think if you have any question, you could write it on the chat box. So when he has attended in this room, next presenter, Mr. Yayan Saiful Marian, to deliver his research titled Hydrodynamic Tidal and Monsoonal Current Characteristic in Pondok Dayung Port of Tanjung Priok Harbor, Jakarta. The time is yours.
Good afternoon to all honorable audience here, and thank you for the opportunity that has been given to me. My name is Yayan Saiful Marian, and in this section, I will present my research with the title Hydrodynamic Tidal and Monsoonal Current Characteristic in Pondok Dayung Port of Tanjung Priok Harbor, Jakarta. Pondok Dayung Port is a new port at Tanjung Priok Harbor, so because it's a new port, so that have very little bit information about that port. So in this picture, you can see this is a Tanjung Priok Harbor, and in the inner red line is my research area, and this is a Pondok Dayung Port. So one of the most important information from a new port is the hydrodynamic characteristics, which are very influential in terms of shipping safety. So from this reason, it will make face the recent question, how are hydrodynamic characteristics in the research area, and how fast is the ocean current speed in the research area. So in this research, I was using a numerical model method with the application of Mach 21, and the research began with the preparation of data such as bathymetry is taken from digitizing Indonesian marine chart number 86 alpha, and the coastline line data is taken from digitizing Indonesian marine chart number 85 alpha, and the tidal data is taken by global tide prediction at Mach 21 application, and wind data is taken from the loading from EGMWF website. So after all data is ready, we can set up in the application Mach 21 flow model FM to create the domains model and to input the initial condition. And the model will running in January for representative on west monsoonal condition, and in the July as representative in east monsoon condition. So after the model is complete, the next step is validation of model simulation with comparison with the observation data sea surface elevation from tidal station owned by Indonesian Geospatial Agency. And then if the validation are good, we can analyze the result of model, and then the last step is conclusion. So this is a picture of the main model by modeling using the flexible mesh or triangular mesh, and the total number of mesh is 3,840, and the mass size is 2.52 nautical miles square, and the smallest allowable angle of triangle is 26 degrees. And this is picture the focus area or observation area, and then station 1, stations 2, station 3 are located in the inner jetty pool. The station 4 are located in the entrance of jetty pool, and the station 5 and station 5 are located in the entrance of jetty channel. So this is a picture of this is a picture comparison graph of sea level elevation between the model result and the observation data in January. We can see the blue line is the observation data, and the orange line is model simulation data. We can see in the picture there's not much difference between the model result graph and the observation graph. So based on calculation using the Admiralty method, we get from cell value the observation data show the type of tide in the research area on January is diurnal tide, and the model result also show the same tidal type too. And based on calculation using the root mean square error method, so a value 0.0458, we saw that the simulation model is close to the real condition based on Hugh and Bentel research in 1998, which state that a simulation model is said to be good if it has an error rate below 0.05. And based on correlation calculation using the Pearson product common, we get value of using the Pearson product common, we can get value 0.9843, which means that the simulation result of the model have a strong relation. And this is picture. This is picture of graphic comparison of sea level elevation in July. We get from cell value in July, both of the simulation result on the model and the observation data show the diurnal data type 2. The error rate in the July simulation result in 0.0432, which means that the July simulation model is also close to the real condition, and July's correlation value so a value are of 0.9814, which means that there's a strong relation between model simulation and observation data. So this is picture of simulation model of pattern current at January. We can see in the picture when the conditions are toward the flood tide, the ocean current lead into the pier pool. You can see in the current pattern lead into the pier pool. Sorry. Otherwise, when condition toward F tide, the ocean current is come out of the pier pool. We can see when the toward F tide, the pattern current is come out from the pier pool. And then this happened during spring tide and neap tide condition. And this is a picture of simulation result of the current pattern model in July. We can see in the picture, the current pattern in July is also as same as the current pattern in January. And when the condition is toward to flood tide, the current pattern is lead into the pier pool, and when the condition toward to ebb tide, the current pattern is come out from pier pool. So we can take a conclusion. This is so that the pattern of ocean current in the research area is not strongly influenced by wind, but is more influenced by tide and the shape of the coastline. This is a picture of graph of the speed of ocean current at observation station in the research area. where the station 1, station 2, station 3 are located in the JT pool area, and station 4 are located in the entrance of JT pool, and station 5 are located in JT pool entrance channel. So, and we can see on the graph of January and July, we can see a very significant difference between the speed of current outside JT pool. You can see this is outside JT pool and inside JT pool. So we can take the conclusion is from that the breakwater in the research area is very effective at holding the current velocity, so that the current velocity in the pier pool area is smaller than outside the pier pool. So this will make it very easy for the ship when it will dock at the Pondok Dayung pier. Then this is a picture of comparison graph between model simulation using tidal effect and model simulation with tidal and wind effect. We can see in the picture the black line in the result of simulation with the influence of tide only, while the orange line is the result of a simulation with the influence of tide and wind effect. So we can take conclusion from this picture. The influence of tide and wind on current speed can be seen by the high current speed when the wind direction is in the same direction as the current pattern at time of high tide. Finally, we come to the conclusion. First conclusion, this hydrodynamic simulation show a high tendency to reconstruct the dynamic condition of sea level elevation and current and Pondok Dayung form. And the underlying characteristics are possibly influenced by tide rather than the wind effect in both the west and the east monsoon. However, under certain conditions where current movement occur due to tide in the direction of the wind gust and increase in the driving force tend to also accelerate the current speed. And the second conclusion, this circumstance indicate a very effective breakwater construction as a sea wave protector toward ensuring the ship's stability and safety during maneuvering and dock operation. This result serves as a possible reference for captain in the navigation planning process ship maneuvering the port basin area, particularly by considering the direction and current speed in the jetty island. So my research is acknowledgement. All authors having equal contribution as principal investigator. The study is collaborative research among the Marine Research Center of Costa Rica, STAL, and the National Center for Hydrography and Oceanography, or HUSHIDROSAL, in the framework of the Indonesian Hydrography Council Communication Forum. Furthermore, the research was conducted before the COVID-19 pandemic at the Marine and Coastal Data Laboratory, Marine Research Center, the Republic of Indonesia Ministry of Marine Affairs and Fisheries, while the author discussion conducted virtually during the pandemic. The manuscript preparation and its publication funded by the STAL fiscal year 2021 for the research project of the Path to Fusion Oceanographic System prototype development. The map legend in the figure 1 was plotted using the ocean data view. So that's all my presentation. Thank you for your attention. Good afternoon.
Invite her to deliver the presentation titled on the investigation of vertical uncertainty of depth sounding in a shallow environment with muddy seabed, preliminary result from a launch operation of a dual frequency echo sounder. Miss Gabriela Alodia, have you attended in this room?
Yes, hello, good morning.
Okay, good morning. Miss Gabriela Alodia, the time is yours.
Okay. Before I do my presentation, actually, I gave the video to the committee, if it's possible to play the video. So I'm not running out of time, you know.
Okay. Can you please play the video, the committee?
Thank you. Hello, everyone. My name is Gabriela Alodia. I'm part of the Hydrography Research Group, Faculty of Earth Sciences and Technology, Institut Teknologi Bandung, and today I'm going to present to you our research titled on the investigation of vertical uncertainty of depth sounding in a shallow environment with muddy seabed. This is the preliminary results from a launch operation of dual frequency echo sounder. So as you can see in the title, we are going to employ an echo sounder with dual frequency. And as we know, an echo sounder is an instrument that will give us a measure of depth using an acoustic wave. And in this dual frequency echo sounder, we will receive two types of depth, one from the high frequency, one from the low frequency. And we would like to compare those depths with a kind of a physical depth. So the important thing that we would like to highlight here is how much are the vertical discrepancies within these three types of depths. So why is this study important? Basically, our purpose is to determine the depth in muddy waters. Why muddy waters? Well, in an environment that is dominated by hard sediment, it is easy for the acoustic wave to determine the depth because the solid and water interface or the boundary is very, very easily detected by the acoustic impedance. So there's a very distinct acoustic impedance between, for example, if we've got the water and we've got a smooth seabed, such as sandy beaches, the depth would be just basically here. Also with rough seabed, it's the same thing as well. So the determination of depth, one of them is important in the safety of navigation. So there's a term that is called nautical depth, which is basically the level where the physical characteristics of the bottom reaches a limit beyond, in which contact with a ship's keel will cause either a damage or unacceptable effects on controllability. So for example, in a smooth seabed, this would be the nautical depth because we don't want our ship's keel to reach that critical limit. We don't want our ship's keel to be crashed. Same thing with the rough seabed, but because it's a rough seabed, we would just define the nautical depth in which the area is the shallowest. So these are the two nautical depths in an environment that is dominated by hard sediment. But what about an area that is dominated by muddy sediment? We've got the hard sediment, we've got the soft sediment, and we've got the suspended sediment, and it's all mixed up, and we never know where the boundaries are. So in a muddy water, the nautical depth term is redefined as the level where the navigable fluid ends and the non-navigable seabed begins. So instead of damage, that's more of the controllability and the maneuverability of the ship, because as you can imagine, as the ship reaches a certain depth in which the water is not fluid anymore, it's rather viscous, it's going to be harder for you to navigate within that water. So originally or conceptually, the nautical depth is defined as where the soft sediment ends and the hard sediment start. But we don't even know which depth is actually determined by the acoustic waves or by the echo sounder. So we designed an experiment using an acoustic and a physical measurement. The acoustic measurement is determined by a dual frequency echo sounder, as I have mentioned before. So if this is our surface model, this is our transducer of the echo sounder. In muddy waters, the characteristic is actually we will receive two types of depth. One is from the high frequency, which is going to be shallower, and another one is from the low frequency, which is going to be deeper. So we carried out a static survey in which we carried out the sounding in an anchored vehicle. So it's going to be continuously emitting acoustic signatures to the seabed. And we did also a dynamic survey in which we designated the survey lines as usual, as in the usual survey. So during the static survey, we also carry out something that is called a physical measurement using GraviProbe 2.0 free fall penetrometer. So the free fall penetrometer looks like this, and it will basically free falling using a winch, and it will decelerate at the point where the solid sediment begin. So we would like to compare the so-called physical depth with the acoustic depths. So this is our investigation domain in Patimban. We can already see that the domain of investigation is enclosed by two river outlets, the Cipunagara and Cimanuk. So it's very, very sedimented. And another thing that it's actually undergoing a port development phase. So depth determination takes a very, very important part in this part. And also we are focusing only at this site. So in the Northeast Breakwater pre-construction site, we already have the breakwater names determined by the project management team. And this is our survey lines. So if this is our breakwater line, we designed 4 survey lines perpendicular to that breakwater lines. And in each line, we've got 9 probing stations. So we've got 4 at the right side and 4 at the left side, and then we put not in the middle, so we know that it's the middle. And the others are named from A to H, from the north to the south. So we'll be focusing on Tau 46A, EB2A, and the H's for the next static survey. So for example, this is Tau 46A and EB2A. We can determine the physical depth when the penetrometer decelerates in a substantial gradient. We can also see that the static shear strength is actually oscillating during that gradient of acceleration or deceleration. So these two are measures or profiles from the physical measurement from the free fall penetrometer, and these two are the physical depth that is plotted on top of the high frequency and low frequency sounding. So we also would like to eliminate these data outliers because we don't want them to be included in our calculation. Also, we carried out a quality check or quality control to make sure that the acoustic depth within this static point is within 95% confidence interval to comply to the ISO S44 standard. This is another example of the results. So you can see that the discrepancy between the physical and acoustic depth varies from one place to another. So we carry out this type of observation in each point. We've got 36 points, and we exclude the physical depth that looks as if they're the outliers. So there's a whole QC going on in here, but basically we observe the discrepancy between these 3 depths in all of them, and we exclude the physical depth that is the furthest, and I will show you in the next slide. Also, we already see inconsistent depth resulting from the low frequency sounding, and we need to really focus on that. So this is the dynamic survey. These are the seabed profiles from H to A, from Tau 46 to EB2. So you can already see that, So all the depths in here, both the acoustic and the physical depth, have been corrected to the tides because the static and the dynamic survey are separated in several days. So after they are corrected to the tides, we can already see that there are 2 physical depths that are that looks like outliers, so they are excluded from our next computations. And another thing is that this one, although it's not visually seen, it's actually needs to be excluded based on our statistical quality control. So after we remove them, we have a look at the high frequency depth and low frequency depth, and you can see that there's quite a consistent discrepancy between these two, and the high frequency is consistently shallower than the low frequency. We can also see that most of the physical depth in Tau 46 and EBD2 lies very, very close to the low frequency acoustic depth, but not as much as in the Tau 43 and EB2. Why? Well, from our observation, we can see that the low frequency acoustic depth in deeper area tends to give us more inconsistent measurement. So for example, in South 46, it is actually generally deeper towards the north, and we can see that there are a lot more inconsistent measures in the deeper area compared to the shallow area. We can also see that it's generally deeper towards the east, and we see or we observe a lot more inconsistency in the low frequency depth compared to the shallower area. So in conclusion, we present a preliminary information of the vertical discrepancies between the acoustic and physical depth, also between the two acoustic depths. So we can see that the high frequency echo sounder tends to underestimate the physical depth, the low frequency tends to overestimate it, and it actually returns inconsistent depth measures in several areas. And the most important thing is that we quantify the vertical discrepancies. So these are the vertical discrepancies. This is between the high frequency and low frequency. This is between the gravity probe or the physical depth with the high frequency and the low frequency. And actually this quantification is sort of the state-of-the-art information on the relation between the acoustic and physical survey in a muddy environment. So this is a novel finding in this area, and we would like to acknowledge or thank all the people who have been involved in this research, specifically to the Faculty of Earth Sciences and Technology, Institut Teknologi Bandung, who have made this dissemination of the research possible. Thank you for your attention, and we would like to welcome any questions.
Thank you for your presentation. I think this is the great presentation. Is there any question? Okay, well, we have can it record the slope of the extreme seabed because it has a huge angle. Could you record the slope of the extreme seabed? Thank you.
Okay. I don't think I get the question. So recording the slope, you're saying, because the echo sounder that we're using is a single beam, so you don't have that that angle. I don't. Yeah, is that what you mean, or?
No. If the seabed, the mid slope of seabed is high, is huge, then it would be the huge angle. That's the echo sounder can record this slope.
Oh yeah. Yeah, so the interesting thing here is actually because our study area is in the northern part of the Java Island, and the northern part of Java Island, the slope is actually very, very smooth. So of course, I would say that it's easier for echo sounders to measure areas with extreme slopes than the slope that we usually see in the northern Java Sea that is very, very smooth. So yeah, of course, the echo sounder can do that. But yeah, it's more challenging for us actually to do that in a very, very smooth slope. I hope that answers it.
Okay, thank you. One more question from Mr. Fajar. Have you prepared your formulation for patent?
Actually, this is the research is still going on. So the first one is actually published in this MSAT conference. It's going to be peer reviewed, I guess, for that one. And the plan is actually to prepare a journal publication out of this. But yeah, I think it's very important to know about this because when we are surveying in muddy water, the idea of this research is because you're using acoustic waves and we don't even know how much trust we can put to our echo sounder, right? So that's why we want to compare the sounding with the physical one. But I think the big idea in here is if you want to do a survey in muddy waters, in a water that is, you have very fine sediment, I think it's better for you to use dual frequency echo sounder because from our finding, your depth is actually between those two. So if you use, for example, only high frequency, then you underestimate it. If you only use low frequency, then you underestimate it. But if you use dual frequency, then it's going to be in the middle of it. So you can kind of, feel where the depth is going to be. Yes, so you will have two depths. So can I share my screen here? Yeah. Okay. Okay. Wait, sorry. I will try to share my screen. Can you see my screen now? Because
Still waiting. Okay.
Okay. Yeah. So for the dual frequency, basically you will have the same echo sounder, but the echo sounder itself will emit two types of waves, the high frequency and the low frequency. So the high frequency will give you the depth in the red. Can I do the red depth? Those are the high frequency, and the low frequency is the blue depth. So the physical is the black one. That's what we are trying to compare in here. And as you can imagine, sometimes they are exactly in the blue one, sometimes they are in the red one, sometimes in the middle. And the final answer is basically this number. So that's kind of the average of the numbers that we are processing. So if you are if you're using this for a practical reason, for example, you're doing dredging because it's very important to know how trustworthy your echo sounder is. For example, if you underestimate it, then you're actually dredging nothing, if you can imagine that. And also about the slope, you can see that in this area, you can see that this one is around 9, and this is only like 9 point something. So the gradient of depth is very, very low. Even from here, this is the shallowest, it's around 9. If we are looking at the low frequency, and this one, the deepest one is 9 point, it's not even 9.5. So yeah, it's a very interesting environment to be surveying on. Yeah, it's good but costly. Well, it's yeah, it really depends on what you want to use it for, because if you're using it for dredging, then it's going to be even more expensive for you to dredge more if you use a wrong type of echo sounder. That's basically what I'm going to say. Thank you.
Okay, thank you for your responses. I think we have to move on to the last speaker, Ms. Dinda Romika Junita. Have you attended in this room?
Yes, I already attended.
Okay, I would like to invite the last speaker, Ms. Dinda Romika Junita, to deliver the presentation titled Overview of Planktonic Foraminifera in Relation to Ocean Current in Sulawesi Sea. The time is yours.
Yes, maybe the committee will play the video. Good afternoon, my name is Dinda Romika Junita, and I want to present our work titled Overview of Planktonic Foraminifera related to Ocean Current in Sulawesi Sea. For introduction, foraminifera is a single-cell eukaryote. It commonly used in study of recent and ancient environmental conditions because they are very sensitive to ecological changes. Foraminifera secrete solid carbonate skeleton called test. The test is divided into a series of chambers, which increase in number during growth. The specific characteristics of their structure are the basis of their usefulness. Foraminifera was separated into two types following their life strategy: benthic, which is a bottom-dwelling species, and planktonic, species that free-floating within the water column in the open ocean. The planktonic species will lose their ability to stay in the upper ocean at the end of their life, so the test will be sink to ocean floor and become part of the sediment. It has been well confirmed that the abundance of foraminifera in sediment is representing the ocean condition above where it was deposited. However, planktonic foraminifera is considered as passive particle. Their movement is carried by ocean current. In consequence, it may represent more wider area according to the ocean current pattern. Sulawesi Sea is a more typical open ocean condition. It is the main entrance of the Indonesian through flow, which is a branch of the global thermohaline circulation. It carries water mass from the Pacific Ocean to Indian Ocean through Indonesian Sea. The ITF enters the Sulawesi Sea through Mindanao Current and discharges to Indian Ocean through Lombok Strait, Timor Passage, and Ombay Strait. This study is to examine the distribution of foraminifera, to identify the biozone using cluster, and to estimate the lateral distance of planktonic foraminifera. For methods, 10 surface sediment samples were analyzed. These samples were obtained using gravity core in 2016. Sample sediment were washed while filtered, then samples were dried in the oven with 40 to 60 degrees Celsius, and about 300 specimens were separated for quantitative analysis. In quantitative analysis, this engages of ocean current simulated data from the HICOM. And for estimate the lateral distance is using a velocity equation by considering the foraminifera traits and their relation to ocean currents. Result and discussion. The foraminifera that was found is dominated by planktonic type, comprised of 86.3%, and for benthic foraminifera is found in a low percentage. In total, 13.7%. Both diversity and evenness index is categorized as moderate category, suggests the presence of foraminifera in Sulawesi Sea was evenly distributed. For dominance index is categorized as low category, indicating no particular type of foraminifera is dominant. By these three indices, suggests that the condition of Sulawesi Sea is still favorable for the habitat of foraminifera. For biozonation analysis, we obtain two biozones from the cluster method. Group 1 consists of only one sample. It is dominated by benthic species. The sample site is very close to mainland and have the shallowest water depth compared to other samples. The other 9 samples belong to Group 2. It is dominated by planktonic species, although almost all the samples contain nearly similar dominated species, but significant percentage shift of several species resulting subgroup division. This foraminifera biozone separate sample as 10, the only sample collected from the neritic zone. It also dissociates as 4 sample from lower abyssal zone. It suggests that bathymetry strongly influenced the abundance and the diversity of foraminifera in Sulawesi Sea. The last analysis, the current at both depths have the same direction with Indonesian through flow. Because this water mass is the ITF itself, the water mass flows from the Pacific Ocean through Mindanao Bay. Then it across the center of Sulawesi. At this point, the water mass mostly direct towards the Makassar Straits. and partly deflected towards the Pacific Ocean as part of the North Equatorial Countercurrent. By the foraminifera traits and the average current velocity from each depth, the average drift distance during lifespan is shown in the following table. And the green shaded area on the map is the approximate area traversed by the foraminifera to get to the sample site. The average distance during postmortem sinking is different for each sample location. For the sample S3 with depth of 2064 meters, it takes 10 days to get to the seafloor, so the average distance during postmortem sinking is about 101 kilometers. Here we add up the average drift distance during the lifespan and postmortem sinking, so the estimated total distance from day 1 of a lifespan to the sample site is shown in the following table. In the conclusion, 1. Foraminifera trait was found in the Sulawesi Sea is abundant, dominated by planktonic type. 2. According to biosalination analysis, S10 and S4, which were taken from Neretic and lower abyssal zone, were dissociated from the other sample group. It suggests that the depth factor strongly influenced foraminifera in Sulawesi Sea. 3. Considered as a passive particle, the estimated average drift distance of planktonic foraminifera originated from hundreds of kilometers up to 1,000 kilometers away, which is the approximate area traversed by foraminifera is likely from the northern to the western part of the sample site. This research was supported by the project entitled Marine Science and Technology Cooperation between Korea and Indonesia, and the authors would like to thank Marine Geological Institute, which provided samples and all of laboratory equipment during the research. This is the reference that we use in this presentation. I sincerely appreciate that I've had this opportunity to present to you. Thank you so much for your interest and attention.
Okay, thank you for your interesting presentation. Is there any question? Okay, one question from Pak Kennedy. Is there any specific pattern of distribution of foraminifera species in Indonesia waters foraminifera considered as a passive organism? And do you consider the oceanographic data, especially ocean current, trend in Sulawesi Sea as a main factor?
Okay, maybe as a passive organism, here my research is to estimate the lateral distance of the foraminifera itself relating to the ocean current. So here the lateral distance of foraminifera, of course, the main factor is the current velocity itself. And for the specific pattern of the distribution is by the current map that I shown in my presentation. It's similar with the Indonesian through flow. So the pattern of the distribution of foraminifera is like the current velocity, current pattern in the Sulawesi, like the Indonesian through flow. is my answer. If the question is already answered, is enough? Or
Okay, Pak Kennedy, is that enough? Okay, I think it's enough. All good. Okay, thank you for your interesting presentation and responses. And for all participants, I say thank you for your participation. And now I suggest you to come back to the main event because we have a keynote speaker. Thank you. Have a great day. Assalamualaikum warahmatullahi wabarakatuh.
thank you.
Okay, you can come back to the main event now. Okay, for all participants, I suggest you to come back to the main event because we have a keynote speaker. So you can listen to the presentation of the keynote speaker. Thank you.
Seperti memberikan analisis cuaca tentang bagaimana suatu keadaan itu harusnya dilakukan. Umumnya mereka bekerja di perusahaan seperti pertambangan, perminyakan, dan pertanian. Ada juga lulusan-lulusan dari kami itu yang menjadi kepala departemen di BPPT dan kepala departemen di BMK.
Menjelaskan tentang prospek lulusan oceanografi. Untuk lulusan para oceanografi biasanya terkonsentrasi menjadi 3 bidang, yaitu adalah seorang peneliti, menjadi seorang surveyor di lapangan, atau bahkan menjadi seorang analis di suatu perusahaan-perusahaan. Dan di sini untuk peneliti sendiri biasanya untuk mahasiswa yang ingin melanjutkan studi di berbagai universitas dalam atau di luar negeri, seperti Tokyo Institute of Technology, di Hamburg University, atau bahkan bisa sampai Massachusetts Institute of Technology. Dan untuk field surveyor, itu bagi orang-orang yang suka kerja di lapangan, tapi khususnya di laut. Contohnya di perusahaan seperti Schlumberger, di perusahaan Fugro, atau perusahaan seperti Pagio. Dan yang ketiga adalah sebagai seorang analis lingkungan. Biasanya dibutuhkan untuk memberikan informasi kepada perusahaan-perusahaan yang melakukan industri migas atau pertambangan. Di sini seperti Freeport, Newmont, atau juga bahkan perusahaan minyak seperti Pertamina, Total, atau bahkan British Petroleum.
Geodis itu sebenarnya bisa bekerja di mana-mana nih ya. Jadi untuk melakukan sebuah kegiatan kita butuh perencanaan. Geodis itu bisa mulai dari sebelum perencanaan untuk merencanakan pemantauan sampai evaluasi gitu kira-kira. Jadi kita bisa bekerja di manapun, BUMN, minyak, apalagi perusahaan yang butuh survei atau peta offshore, ya pegawai negeri juga bisa lah, BPN atau BIG gitu.
Biasanya lulusan geologi ini masuknya ke industri, apakah itu industri perminyakan, industri pertambangan, ataupun industri panas bumi. Tapi tidak sedikit juga lulusannya menjadi dosen, ataupun konsultan, ataupun orang-orang yang bisa keluar.
An Indonesian passenger plane carrying more than 60 people has gone missing shortly after takeoff from...
The tragedy that left deep sorrow for the Indonesian people came at 2:30 p.m. local time on Friday, January the 9th, 2021. Sriwijaya Air SJ182 plane with the Jakarta-Pontianak flight route crashed 4 minutes after takeoff from Soekarno-Hatta International Airport. The plane, carrying 62 passengers, experienced a drop in altitude of 10,000 feet in 1 minute, which...
Ladies and gentlemen, may we have your attention, please? The conference will start in a moment. Ladies and gentlemen, we will move on to the second parallel orals presentations. We have provided 4 breakout rooms and 1 additional breakout room for the sessions. We kindly invite the speakers to the designated rooms and participants to join the room of your choice. Room A holds a mini symposium titled Marine Hazard and Coastal Degradation on Tsunami and Modeling and will be moderated by Karina Aprilia, STMT. Room B holds a mini symposium titled Marine Geodesy, Satellite and Operational Oceanography and will be moderated by Elgo Dwistra Kartiko Putro. Room C holds a mini symposium titled Marine Resources, Conservation, and Integrated Coastal Zone Management and will be moderated by Dr. Rima Rahmayani. Room D holds a mini symposium on partnership and will be moderated by Yvonne Rajawane, PhD. Room E is a special room. This is additional. You will see it on screen. Please be advised regarding the rules, topics, and schedules for joining the session. Please join the meeting of your choice through the breakout rooms provided. Should you encounter any difficulty, please contact us for assistance. Please be reminded to go back to this main room at 3:30 Western Indonesia time. Thank you and enjoy the conference.
That we will have each presentation, and you can ask the question. You can drop the question in the chat box or.
Recording in progress.
Senior Ministry of Marine Affairs and
everybody. My name is Yvonne. I'm your moderator in session. So in this session, we will have 3 speakers that talking about Pak Kus. I call him Pak Kus. Pak Kus, are you ready? Sorry, can you hear me? Bapak Ibu, apakah suara saya terdengar dengan baik? Good evening, ladies and gentlemen. Nice to have you, all of you here. And in this room D, we will talk about partnership session. And we have 3 speakers, they're prominent speakers. The first one is Ibu Nani Hendiarti, but unfortunately for this occasion should be replaced by Dr. Kus. And the second one is Dr. Hansan Park from NPCRC. And the last one is Ibu Nelly Floridariema from BMKG. So maybe I will start with Pak Kus. Pak Kus, you can share your presentation. Pak Kus is my, he was graduated from the Japan University in Kyushu University for his PhD. Is Pak Kus is already inside this room? I will check. Oh, not yet. Sorry, I will. So Pak Kus is okay. Pak Kus, are you now in this room?
Yes.
Oh, thank you. So Pak Kus, now we will start our presentation. You have about 20 minutes, 30 minutes to send to introduce your present your presentation, and we have also at the end of your presentation with Q&A session. Okay, please, the time is yours.
Okay, thank you. I would like to start my presentation here. Could you see my slide?
This is clear, but would you like to make it a screen? Okay, thank you.
Okay, thank you for this opportunity. Thank you for this opportunity to ITB for this occasion to invite Dr. Nani Hendiarti, but by this time she has another duty. So on behalf of her, I would like to present this presentation with the themes National Program on Coastal and Marine Environment, Blue Economy, Blue Carbon, and Marine Debris. So we do hope that this title is suited with this workshop or seminar. For the non-conventional resources, we have 15% from the maritime economic potential, about 1.33 trillion per year, and 16% from cultivations, and then biotechnology industry 14%, mining and energy about 16%. However, the fishing catch only 1% still, but maritime industry quite high, about 15%. Regarding the blue ocean economy, we have challenge on the around 38% of fisheries in the national ocean are overfishing, and then 1/3 of Indonesia's coral reefs are in critical conditions. And then coastal ecosystems such as mangroves experience degradation about 50,000 hectares per year. However, we actually curious as well regarding this 50,000 hectares per year, because in some in other literature it's mentioned about less than 14,000 hectares per year. And then marine debris has an impact on human health, the tourism, as well fishing industries, and damages ecosystems. The economic losses due to plastic waste are more than 450 million per year. This is the challenge in blue ocean economy. Regarding the carbon pricing potential in Indonesia, for mangrove, we have about 3.31 million hectares. It is about 48% of total mangroves area in Asia, and or 20% of the world's mangrove. The carbon storage value is around 650 tons per carbon per hectare, equivalent to 33 gigatons of carbon for all mangroves in Indonesia. As well, we have potential through peatland and the rainforest. This is we are talking about the blue carbon actually from mangrove and from peatland. And the final is Indonesia has 75 until 80% of the world's carbon credit that comes from forests, mangroves, peatland, seagrass, and coral reefs. Indonesia currently finalizing the presidential decree on carbon pricing. This mechanism is carried out in order to meet the National Determined Contribution or NDC targets through carbon trading, result-based payment, carbon tax, and other schemes. The policy on carbon pricing includes the following main contents: NDC, GHG instruments, carbon credit, and low carbon development. This is the status of mangrove worldwide. like we mentioned that Indonesia has about 20% of world's mangrove forest. We can see, so we are the highest one for the mangrove coverage. And the second one from South America, and the third from in North and Central America. And then in East Asia, only 0.1%. In national program, we do develop the mangrove rehabilitation, and we has announced during 2021 that we developed a roadmap until 2024. We aim to rehabilitate the mangroves around 600,000 hectares. So it is very ambitious, national ambitious to achieve this target. And we ask the stakeholders from ministries and institutions, as well from NGOs, community. Every stakeholders we invite to give the contribution to these rehabilitations. And then about I would like to mention about National Oceanographic Data Center. The policy components NODC, managed system, and then data policies and principle, legislations, implementation, capacity development, and human resources. That's all about the National Oceanographic Data Center. And then NODC development roadmap during 2018 until 2022. Maybe in here, Hanson as well would present about this as well. The first in 2018 about the academic papers and ministries and institution input, and then 2019 analysis and data exchange, and then 2020 management for knowledge, and then 2021 network for sustainability. It means this year, and then 2022 interoperability IoD. Now come to the marine litter policy Indonesia overview. Marine debris baseline of Indonesia. According to NPAP 2017, our marine debris is about 650,000 tons. However, that data from World Bank mentioned in 2020 about 201 until 552,000 tons. However, LIPI 2018 mentioned about 270 until 190,000 tons. Under the presidential regulation number 83 year 2018 on marine debris, Bapak Presiden, Bapak Jokowi Widodo mentioned that Indonesia will reduce waste by reduce, reuse, recycle until 30% to in 2025, while target reduction marine plastic litter as much as 70% in 2025. Under the presidential regulation number 83 2018 concerning marine debris handling underlines the formation of the National Coordination Team for Marine Debris Handling. And then the decision of the Coordinating Minister number 69 2019 concerning the implementing terms of the National Action Plan on marine debris handling underlines the structure of the implementing team for the National Action Plan on marine debris handling, or PSL. There are 5 strategies of the National Action Plan. The strategies 1, national movement to increase the stakeholders' awareness. And then strategy 2, land-based waste management. Strategy 3, waste management in the coastal and marine area. Strategy 4, funding mechanism, institutional strengthening, monitoring, and law enforcement. Strategy 5, research and development. National waste management target and indicator. Under the President Regulation 97 2017 in Jakarta Transnas mentioned that 30% waste reduction in 2025 and 70 waste handling in 2025. Under the Presidential Regulation 83 2018 on marine debris handling, it is mentioned 70% of marine debris reduction in 2025. So this regulation is in line and strengthens each other. This is the mapping of stakeholders and flow of plastic waste in Indonesia. I think this as well common in everywhere in the world. And then plastic flows, plastic waste flow in Indonesia. So all the waste goes through the linkage into sea or lake and rivers, and then some dumping on land, open burning and dump sites, and some as well manage disposal and recycling. So and it is goes through to linkage into water, and the manage and manage waste about 2 million tons, but the mismanaged still high, 4.1 million tons, and linkage to water body about 0.7 million tons. This number is in 2017. National Action Plan here we can see year by year 2018, 2019, and 2020. And the result is total plastic waste in the ocean is experiencing a 15.3% decrease. It is a good number. Amount of the plastic waste is about 600,000 tons in 2018. As well, in 2019, down about 8.1% from the previous year. And then in 2020, decreasing about 7.9% from the previous year. This is the scenario toward achieving 70% of marine debris reduction in 2025. So in 2021, about 25.90% of the marine debris reductions. And I think it is still on the target of the 2020. Regarding the technology we apply and like for the river and marine debris collection technology, there is a trash collector in the river, and then waste processing technology, some plastic used as plastic tart road, and then circular economy implementation. The development of the 8,434 waste banks in 2020. So it is a huge number regarding the waste banks. And then marine debris handling in coastal areas and small islands. Integration of waste management module into primary education. Behavior change communication program. We do programs like behavior change strategy. How the behavior change strategy should be conducted step by step guidance. And other stakeholders' contribution in regards to Presidential Regulation Number 83/2018. We involve the local government, private sectors, and international cooperation. Just for the conclusions, Indonesia is strongly committed to reduce plastic waste in the ocean, and various supporting policies has been issued and marine debris handling activities has been carried out, resulting in about 15.3% reduction in Indonesian marine debris, focus on accelerating the remaining 54.7%. Indonesia is open to collaboration with partners, including the government of Korea for this instance, to jointly deal with the issue of marine debris considering its transboundary nature. So I mentioned the Republic of Korea because so far we have the cooperation with ROK. And then regarding the economic ocean economy and blue carbon, we are try to maximize the opportunity to explore and exploit the natural resources and then how to sustain the outcome from these natural resources. And this exploitation of these natural resources should be for the prosperity of the people of Indonesia. That's all, the moderator. What I have, what we could present in this occasion. Thank you for your.
Thank you, Pak Kus. Very nice presentation, and we have a new insight about the blue carbon, also marine debris in Indonesian, because we know that the Ministry of Coordinating Maritime is the leading ministry for this subject. Thank you very much. So now I will open the discussion. If there is any questions. Is there any question? Okay. Do you have any question, or maybe you can raise your raise hand by the reaction icon, or you can just directly ask to Pak Kus Prisetia Hadi. Now, maybe I forgot to introduce his job now. He's now Pak Kus Prisetia Hadi is now the Assistant Deputy for Climate Change and Disaster Mitigation from the Kemenko Marves, and he was also graduated from the Japan University for his PhD. Okay, I open the Q&A session. Is there any question? If not, maybe I will ask for you, Pak Kus, because you have very nice presentation. The first one is related with the blue carbon, as you mentioned that we have a very huge area of possibility to be a blue carbon sector to increase our economy from the blue carbon. So in the reality, or in the fact that how many percent or from our blue carbon potential that was already exploited, yeah, or how many more, can you explain more about the program in reality about the blue carbon? Thank you, Pak Kus.
Thank you, dear moderator. Maybe I will describe a bit on the degraded area of mangrove from 3.3 about 3.3 million hectare of mangrove. It is about 600,000 hectares in critical condition. So the government through the national program try to restore the degraded land of mangrove, and from 2021 until 2024, we try to rehabilitate the critical mangrove. So this is the potential we can sell or we can recycle the blue carbon. As you may know that the blue carbon of mangrove consists of 4 times of the carbon sequestration from the tropical forest. Even from the tropical forest, mangrove still has a big capability to absorb the carbons. So it is a very potential for Indonesia to develop this very potential blue carbon. So Indonesia could sell the blue carbon requisitions from mangrove to the buyer from international, even from international. So how serious the government on this matter? So blue carbon will be in the near future will be one of the sector as the mitigation sector for national determined NDC contribution. So far, blue carbon not yet included in our national NDC target, but in the near future, it will be one of the most prosperous sector to be included in the sector of NDC. That's all. Maybe what I could explain on the blue carbon.
Thank you, Pak Kus. It's very comprehensive information about the exploitation of blue carbon and also potential of the blue carbon in Indonesia. So, is there any question from the floor? You can raise your hand, Pak Hansen. Okay, please. You can ask directly to Pak Kus.
Yeah, thank you, Ibu, and thank you, Pak Kus. Yeah. Thank you for your good presentation and your perspective on the blue carbon and also marine debris and many things. And especially thank you for mentioning about the Republic of Korea government cooperation. Yeah. And actually we have already some cooperation on marine debris, and maybe as a co-director of MTCIC, actually I would like to ask about is there any support? Is there any needed for supporting from scientific sector? I mean, MTCIC is focused on science and technology, so we also will launch some specific project using ocean satellite or something based on numerical modeling. So I wonder, Indonesia government also need some that kind of technical supporting is needed or not, or if you have a specific thing, is if you can let us know, that will be very helpful for our cooperation. Yeah. Thank you.
Pak Hensan, Ibu moderator, saya ingin klarifikasi ke Pak Hensan.
Okay, thank you very much. It's directly connected with your presentation.
Pak Hensan, do you mean it is for the general circumstances or not only marine debris? Yeah, maybe blue carbon as well.
Yeah, any sector actually, blue carbon or marine debris.
Yeah, I will take an example for blue carbon, especially for mangrove. Mangrove in Indonesia, there is inside the forest area, and there is outside the forest area or nearby the coastal area. So for the inside the coastal forest area, so it is when we would like to restore or rehabilitate the critical area of mangrove in there, we have a difficulty for accessing the degraded area. So I think in near future we need technology of drone to planting the mangrove trees. So that is one thing. As well, we do need a satellite for sure, because we could detect how many percentage of the forest or of mangrove in critical condition, well, which area still good condition, and so forth. So I think I think Korea could take this opportunity to offer us this the two technology, right? I mentioned maybe a satellite usage, and then a drone, for example, to planting the trees mangrove trees. And for modeling, actually we have the capability. One ministry, that is Ministry for Environment. They have capability on the to make a model of, for example, the marine debris at sea. Yeah. Sorry. So it is very open for our cooperations in the future in this regards. Thank you, Pak Hansan.
Yep. Thank you.
Yeah.
Pak Hansan, is it already clear what Pak who's answer your question?
Yes, it's very clear, and thank you.
Okay, thank you. You can continue with the implementation of collaboration. And so I think there's maybe a lot of question, but we because of the strictly limitation of time, we will stop our presentation of Pak Kus and also the question and answer from Pak Kus. And please we give a big applause to Pak Kus. Okay, sorry. Pak Kus, terima kasih banyak untuk sharing informasinya, sangat berharga. Terima kasih untuk waktunya juga. Mungkin bisa ditutup slide-nya, Pak. Bisa ditutup, Pak. Mungkin kita akan masuk pada presentasi yang kedua. We will now move to the second presentation. So our second speaker is from Korea. I think his name is Hansan Park. Just make a question to Pak Kus. And he's now the co-director of the Korea-Indonesia Marine Technology Cooperation Research Center, and with abbreviation of MTCRC, which is the Intergovernmental Joint Research between the Republic of Korea, South Korea, and Indonesia. And it was the center was established in September 2018. And now he's a principal researcher at Ocean Policy Institute in the Korea Institute of Ocean Technology of KIOS. His research addressed coastal zone management, coastal disaster management, and also maritime boundary delimitation based on geospatial science. So Pak Hansan has various research experience with Pacific island countries, for example, Micronesia, Samoa, and Indonesia, regarding coastal disaster management using the technologies such as LiDAR, GNSS drone, and GIS as a project manager. Pak Hansan was graduated in geography and has a PhD in coastal geomorphology from the University of Kyunghee, Korea. And for this occasion, he will give and sharing the presentation with the title, The Achievement of Cooperation Between Indonesia and Korea in the Field of Marine Science and Technology and the Future Plan. Pak Hansan, please, the time is yours.
Yep. Thank you. Well, thank you very much, Chairman Ibu Ibon. Can you hear me?
Yes, it's clear.
Yeah. Okay. Yep. Thank you. It's very great to present my presentation, especially introduce MTCRC and also achievement and future plan. So the title is the achievement of cooperation between Indonesia and Korea in field of marine science and technology. And I want to just talk about the future plan. So my content, present content is like this. First, just talking about the history of a cooperation between two countries, and MTCRC is actually, I think is a very, good achievement for two countries' cooperation in ocean science technology. Yeah, so I want to introduce MTCIC, general status, and also achievement and plan. So this slide shows the history. Actually, there is more cooperation, before 2011, with between scientists in Korea and Indonesia. In MIPI or the other university has already good cooperation, but this cooperation is based on specific project. So that was Jakarta random substance and coastal flooding research with the ITB and KIOST. Yeah, so it was started at 2011. And then two governments signed on MOU for marine sector cooperation between Ministry of Fishery of Republic of Korea and in Indonesia Coordinating Ministry for Maritime Affairs. And 2018 September, finally, MTCIC is established and Cirebon ITB campus, based on implementing arrangement. So that I want to emphasize our cooperation history is not just only a few years. I mean, over 10 years more, and MTCIC is a very fruitful symbolic result of our cooperation. So yeah, I want to introduce MTCIC, general status first. Yeah, already introduced by Ibu Ibon. Yeah, MTCIC is Intergovernmental Joint Research Center, between two governments, and this center is conducted by two agencies from two countries. For Indonesia, number one, Technology University, ITB is a conduct agency, and Korea side, number one, Ocean Technology Research Institute, KIOST, is conducting this our center. So we have two co-directors, Korea side and Indonesia side. Yeah, Chairman Ibu Ibon, or she is one of the co-directors of MTCIC. And we have 18 staffs, including head and manager and researchers. And we have 3 departments: planning and administration, and research and technology, and education training department. And we have a special decision-making group that is Joint Commission on Marine Science and Technology, which is consists of 10 members from 2 governments. So 5 from Korea, 5 from Indonesia. And I already mentioned the MTCIC is placed in ITB Watibula campus, but also for facilitating communication between ministry, coordinating mission for CMMAI. We also have a Jakarta office in the building of CMMAI. And then next is main activity. Yes, we have 3 main activity and additional 2 sub-activity. First one is a cooperation platform. I mean, we need to make a good cooperation platform between 2 countries to facilitating our science and technology, marine science and technology. And we conduct also joint research, and we conduct a capacity building program. And additionally, we also implement the OD project and support the local community. So cooperation platform, there was many meeting, and that was also very fruitful, and sometimes it's big and very complicated. But just I want to show the many pictures. So we hold intergovernmental meetings and with the ministries, institutions, and universities and others. So it can make a good bridge between 2 countries in field of ocean science and technology. But also including the other marine sectors. So we already have many cooperation and communication with Bacchus, Deputy 4 in CMMAI, and also the other deputies. We have a good cooperation. And second is joint research. We have 4 major joint research topic and 1 additional topic. that topics is decided by two governments in joint commission. So major 4 topic A's are first one, operational ocean forecasting system development. As a user numerical model, we forecast the weather in ocean, including wave, tide, current, and many things. And also we conduct about the optical satellite validation station establishment and application. It is about the ocean satellite. I will talk about this more. And ocean energy and marine debris. Yeah, that is supporting in terms of technology and science. And we have also topic to make a mid-long-term plan, master plan for Korea-Indonesia Marine Science Technology Corporation. So there is one achievement from joint research. Actually, we make a proposal for ocean satellite to Indonesia and Korea government. The title is Establishment of Application System for Managing Indonesian Waters using Korea geostationary satellite. That was based on our joint research topic. So the report will be used for feasibility study report, and we propose to government make a PCA. PCA is a project concept paper, and we finally we got Bapenas's official letter, and there is good news that is Korea government also have good decision for this project. So we can start this project next year. Yeah. So that one is from a small joint research topic we can make a more bigger and more longer project with enough budget support. Yeah. So not only for this not only for this ocean satellite, we can also make a good project. For example, about blue carbon or marine debris or some kind of important issue in Indonesia, we can make it. Yeah. So I saw that this achievement is meaningful. And capacity building program, we have 5 courses, and there is many program is planned, and already we have a joint supervision method expert course. So and also Korea invited the doctoral expert course. So total 60 students per year. They already supported by this program. And unfortunately, COVID-19, we have to conduct training courses by online. Yeah. So I hope finish this COVID-19, we can conduct offline and real training program courses and with us. Yeah. So there's the example. Yeah, last year we also conducted special courses from Korea researchers, and we have an online course. And before COVID-19, some students visit Korea, and they also have some training course. And now next sub-item is activity local community support. We conduct Cherubon Coastal cleanup campaign. And I go to next contents that is about major achievements. So one is that is ICRG survey. ICRG Indonesia Coral Reef Garden. So we conduct ocean basic survey with our equipment and with our researchers. So as the survey data will be very helpful to Indonesian government to manage Indonesia Coral Reef Garden project. Yeah. So we want to continue this survey in this year or in the future also. And we support Sriwijaya search and rescue activity also. Yeah. So just when have an accident, we got a request from CMMAI. So we just go to accident area. We survey some data using our boat and also equipment. So that's meant as our center have to support Indonesian government, if they need, so it is a concrete result, concrete achievement about this. So I can say we already secured some equipment and the researchers. I mean, we have ability to do something. So Indonesian government also knows that, and that is very meaningful result for our corporation. Also. And the next is through OD project, we can secure many equipments for real survey and research. So both multimedia echo sounder, sub-button profiler, CTD, and drone, and GNSS, and numerical model server, and computers, plotters, and vessels, vehicles, and softwares. And this year, additionally, we will secure the additional equipment for marine chemistry laboratory. So nutrient auto analyzer and ICP MS and ADCP tide gauge and weather station, and also spectrometer for analyzing microplastic debris in the ocean. And we got an award from Korea Embassy, 2019, for outstanding achievement award. So and researchers and educator and supporter, and with the master plan of this, but we need to revise it. And now I want to talk about this. MTCC will be International Research Center. I explained that there is 3 main activity, cooperation platform for joint research and for capacity building. But in the future, we will focus on the joint research more. Of course, a cooperation platform and capacity building have to extend it to many fields, for many universities, for many institutions and agencies. But for joint research, that is maybe one of the very essential of MTCC. So we want support government for many issues in the ocean to government, I mean, and by marine survey and analysis expertise. Because we already have secure many equipment, and based on survey and analysis skill and the technology, and that means we can secure good data, and that will have to have good research. But everything is with the international standard. So this joint research part will be in larger than now. So for that, I already mentioned the many equipment have to use for survey and in Indonesia Ocean, and with very expertise scale. So it also very helpful to conduct a capacity building program for many students and or staff in institution or laboratory. And then also I already mentioned the cooperation field also need to extend, including government. We cooperate well with CMMI, but we also extend to KKP. And agency also, RAPAM, BNKG, RIPI, and BIG, BPT, and BKPO. We need to cooperate more. And also university, now we have a very good cooperation with ITB, but also we can extend the IPB, Bogor Agriculture University also. And that were linked with the capacity building program. So now we are open, but we need to promote our capacity building to the other university, ITB, IPB, UI, UNPAD, Gajah Mada, Diponegoro, Hasanuddin. There's many good universities, so we need to extend our capacity building program to many students. And especially a request from Deputy Ibnani, and she suggests to us to make a good program for Korea, and invited the technical education and training program for officials of institutions and ministers, such as MMAI. So that means for official officials, they need also some training. Yeah, so we can invite them to Korea, and we have a 1 week or 2 week training program in Korea. So that will be very helpful to them. Also, it will be also good for our cooperation. But after COVID-19, summary, so Korea and Indonesia cooperation already has 10 years more history, and MTCS is symbols of cooperation. And MTCS has 3 main activity: cooperation platform, joint research, and capacity building. And the major achievements are children capacity building with the project implementation. That means through this ODA project, we can secure and utilize equipment and activity. And ICRG survey and Sriwijaya SAR supporting mission, that man is MTCS is recognized by Indonesia government as an active research center. And ocean satellite project development, that means we have ability to develop a large scale project, and already 60 students for master and doctor program. So we are developing knowledge and skills for Indonesia student. And the MTCS will be international research center with international standard. So we will extend cooperation field agencies and universities, and we will focus on developing ability for marine survey and analysis and statistically. That is my presentation summary, and thank you for attention.
Okay, thank you very much, Pak Hansan, for your interesting presentation, and also opportunity to make a collaboration.
Cooperation with Pak Saleh, Pak Hansan. So it is. It seems that I am the first time to see this such kind of the presentation. So it's make me awake that especially that it is related to the marine science and technology. So like you mentioned, one of them is using the satellite technology. So I wonder whether we could as well develop the stationary satellite that can stay only in Indonesian water. Can you suggest? I mean, I need your suggestions. We have a problem due to the oil spill. It happens. Was happened every year in between Singapore water and Indonesian water. So it occurs less during the not monsoon, and it always happens. So the suspect is the ships pass through the international water and they discharge the oil in the evening, so no one could know what we are doing. So I think one we could explore is how we could detect the oil pollutions actor. So one of the technology may be through the satellite. The existing satellite could not detect who is the actor. Do you know why? Because satellite rotate the let's say the Singapore water only twice a day, right? So we could not detect the actor during maybe evening or maybe in the morning, in early morning. So we could there is a difficulty to find out the actor. because the detection of the satellite is very limited. We need 24 hours in that area. The stationary satellite. So could you give me the how to solve these problems related to the limitation of satellite? Thank you.
Yeah, thank you very much for your good question. Yeah, actually, yeah, that is a very important point for using satellite data. Yeah, there is two kind of resolution. Yeah, you mentioned about the temporal resolution. Yeah, so to monitoring every whole water in Indonesia every day, that is problem. Yeah, so actually geostationary satellite. Actually, this is a different presentation, but you mentioned many issues on the sea. OSP also important. Yeah, it's a good case in US. And yeah, my question is also same. Monitoring every day and everywhere. Yeah, so geostationary satellite just place at one position. Yeah, one sky. Yeah, so they this geostationary satellite can get data every time, yeah, in the same position. Yeah, so new satellite GeoComSat 2B is launched by Korea last year. It's placed in the Maluku Utara sky. Yeah, now GeoComSat to be placed in Maluku Utara sky over Maluku Utara, and then every day take an image, yeah, whole area of this coverage, including Indonesia. Yeah, main center is Indonesia, yeah, actually, and then Australia and Korea also. So every day we can have some data.
24 hours?
No, it's not 24 hours because it covers whole area. So we can take at least one data on everywhere in Indonesia water.
Oh, yeah.
Yeah. So we have to fusing with this ocean satellite data with the other sensing data. Yeah, so, but I would like to emphasize this new ocean satellite is cover whole area of Indonesia territorial sea every day. Yeah, so we can detect something changes in the ocean or including in the land. Yeah, but even that the resolution, I mean, spatial resolution, not too good, but you can detect something. And then we can focus on that area using the other technology or the other remote sensing or drone or something, we can find out what happened in there. So OSPER is also, there is good cases, yes, in using this ocean satellite, yeah, operated in Korea. Yeah, so here is West Sea of Korea. So we can detect OSPER just when it happened, and within one day, yeah, within maybe 24 hours, we can detect something. Yeah, and then we can see what happened and what's the drift direction and the spread, how much, how, where, yeah, something like that. Yeah. I hope my answer is enough for your question.
Yeah, Pak Hansan, but it means in one place only once per day. Once per day we can detect.
Yeah, but everywhere. Yeah.
Yeah, but everyone.
Yeah.
Let's say we need between the water between Singapore and Indonesia.
Mm-hmm.
Yeah. Once per day, right? And once per day.
Yeah. Technically, actually, we have more pre-country, we can get more pre-country data in the same position. That is a policy of operation of this satellite. For example, for Korea, I mean, this is launched by Korea. So Korea area, we take 12 data in a day. Yeah. So if there is some request from Indonesia when we have a good cooperation project, and we can take more pre-country data in Indonesia Sea.
Yeah.
Yeah, so that is, I mean, there is an opportunity to have a more pre-country data in a day. Yeah, using this satellite.
Okay, let's say we can take the data in the border between Singapore and Indonesia. Could you?
Yeah.
During the night, let's say
daytime. In daytime.
In daytime.
Yeah, sure.
We need during the night, Pak Hansen.
Yeah.
Because the actors
Yeah.
discharge the oil, illegal oil.
Yeah. So actually, I mentioned that we were launching a new project that is to make application system. Yeah, maybe we can talk about that later, more detail. Yeah, so we can scheduling for nighttime capturing, data capturing. Yeah, so yeah, it will be good case to utilize this satellite. Yeah.
Okay, thank you, Pak Hansen. Thank you, moderator.
Ibu, your mic is.
Thank you. I will give one more question for the participant who want to ask Pak Hansen.
I want to ask. Not ask. I want to comment. Boleh ya, Bu?
Thank you, of course, for sure.
Yeah. Thank you very much, Mr. Hansen. 안녕하세요. Yeah. Actually, I am Nelly from BMKG, and I do want to thank you to MTCRC that one of staff from BMKG right now study in ITB with the scholarship from MTCRC. So I don't have a chance yet to say thank you. And of course, we are very keen and very eager to have a close collaboration with you. Thank you.
Thank you, Bunali. Please, you can answer, Pak Hansen.
Yeah, thank you very much. Terima kasih banyak for your good comment.
Okay, so because we want to move to the third speakers, but before that, we will give a big applause to Pak Hansen. Ya, to Pak Hansen, terima kasih for Pak Hansen, and hopefully that MTCRC will bring strong development in collaboration with Indonesian institution and other university. Thank you. Okay, now I will introduce you for the third speakers. The name is Ibu. So I will write down. Ibu Nelly Florida Riama. Now he's the head of Center for Research and Development from the BMKG, Indonesian Agency of Meteorology for Meteorology, Climatology, and Geophysics. And with her position now, she is responsible for coordinating and conducting research, development, and engineering in the field of meteorology, climatology, and geophysics. A very huge responsibility. She started her career in the staff submission for meteorology analysis since 1998. And she was then promoted to be the head of climatology network observation subdivision for the period of 5 years, and continue as the head of the agroclimate and marine climate information division. And in 2016, she was promoted as the director of Marine Meteorology Center, which allowed her to manage the provision of information services of marine meteorology and ocean climate in the national level. And recently, she has been working on several national and global marine research which led her to the team that established the CIFDP Indonesian since 2017. She is officiated by the vice chair of the GCOM ATDRR. It was very long job, a long history of job, and then and she was graduated from the in bachelor in meteorology, Bandung Institute of Technology, and continue his master in geography with the predicate of cum laude from the University of Indonesia. And I think she is now already obtained her PhD degree from the University of Indonesia too. Maybe that's a brief introduction about Dr. Nelly Florida Ariama. And now she will share the her presentation. Her presentation is
May I share my screen?
Okay. Or do you want to share by yourself?
Yes, I
okay.
want to share my presentation.
Okay, it's better, yeah? It's better. Yeah. Okay. Okay, time is yours, Ibu Nelly.
Yeah. Okay, thank you very much for the opportunity to be here in such wonderful event, and thank you very much for the invitation from the committee to me, especially from Yvonne. Yeah. The title of my presentation is strengthening in Indonesia ocean research capacity to enhance the accuracy of early warning system for extreme weather events. So I will start with, as you know, that Indonesia as an archipelagic country, we have a very complex land sea distribution and topography, and this make predicting high impact events in Indonesia is quite challenging. Many atmospheric and oceanographic phenomena take place in Indonesia, as you know that we are affected by monsoon, ITCZ, and other regional phenomena, and we also must take into consideration the local phenomena. So for Indonesia, analyzing data over land and ocean near Indonesian waters will improve. We believe it will improve understanding of extreme weather phenomena and their relationship with global and regional impact. So obviously that ocean observation are crucial in our research and to make the prediction, because they can examine the details of the RC interaction process that lead to the formation and intensification of the system. So additionally, ocean observation are increasingly viewed by the forecasting community as a critical part of improving extreme weather forecast. And to meet the need for the oceanographic data in Indonesian seas, our agency, who has a task to give information on weather and climate, continues to strive to improve the availability of such data through what we call the strengthening of marine meteorology system program for the next few years. In these programs, we will try to complete the availability of meteorological and oceanographic monitoring system over our waters and near the coastal, of course, with many equipment such as automatic weather station in the coastal area, automatic weather station at the vessel, high frequency radar, disturbed buoy, profiling boat, and other equipment. So we believe that the increasing of the maritime meteorological observation network will support the safety and efficiency of various national marine activities. And of course, it will increase the accuracy of the information and early warning of our marine weather. And through this project also, we want to disseminate and socialize our information, marine information to the, sorry.
The session is...
MOU was signed between the Ministry of Oceans and Fisheries of Korea and the Coordinating Ministry for Maritime and Affairs of Indonesia. In May 2018, the implementation arrangement was signed. In September, the MTCRC was opened at the Itebe Cirebon campus. Afterward, we are continuing various activities for the construction of the boat Ara, supporting the accident of Sriwijaya Air Flight, and planning for the installation of a marine chemical analysis lab. The MTCRC is jointly operated by the KIOST, the leading marine science and technology research institute in Korea, and the Itebe, the top science and technology university of Indonesia. There is a joint committee composed of 10 governmental representatives of both sides as a key decision-making body. Also, under the leadership of co-directors, the planning and
Recording in
You can
progress.
share your presentation first.
Yep. Can you see the my screen?
Clear, it's clear. Perfect.
Okay. And not just talk about the observation. On the other hand, we also need to strengthen our ocean research capacity to improve the accuracy of our early warning system. And I will show you several activities have been conducted. The first one is what we call the Years of Maritime Continent. This is a multi-year international program to study the weather climate system of the Indo-Pacific maritime continent and its global impact. And the scientific issues are diurnal cycles, synoptic systems, interseasonal oscillation, monsoons, oceans, air-sea interaction, troposphere interaction, aerosol, and of course the prediction improvement. So we have many activities in this project, and there are, because this is an international program that so many countries also involved, and we also involve our national community, of course. But because of the pandemic, some of the activities has not been done right now, and we will hope to complete these activities in the next 2 years. So I will show you one of the activities that still are pending right now is what we call the Terra Maris. This is the maritime continent driver of the global system. With this, through this program, we will have many observation, from ground observation and also flight observation. So this is a collaboration among many agencies. For Indonesia, it's BMKG and LAPAN, and international collaborators are University of East Anglia UK Met Office and also from Bureau of Meteorology Australia. So the background of these activities is, as you already, as I have already mentioned on the first slide, that the archipelago with this tropical island is very complex with sea and land distribution, and the high solar input warms the surrounding sea, supply abundance of moisture to the atmosphere. So deep convective cloud rise over this island every day, leading to average rainfall rates in excess of 10 millimeter per day. It's approximately 3 times of the rainfall rate over the UK. So with the tremendous heat energy is released by, we believe this heat source drivers giant, overturning the circulation in the atmosphere. So we want to have a study on this. The plan is we will have 3 sorties in the land, with the aircraft also. We want to see the land sea breeze, and the third one is the northeast monsoon cold surge. The other activities under the year of maritime continent that's still pending is what we call the equatorial line observation project. In these projects, the interaction within atmospheric equatorial convectively coupled Kelvin waves, leading modes of eastward moving convection of time scale between several days and 3 days will be investigated. So we do hope that we will do the observation in this year. We do hope, but maybe it's still pending because of the pandemic. We will see. So this is the science topics. We want to investigate the mean diurnal evolution of vertical structure of convective heating over Sumatra and Borneo, and to investigate the evolution of upper ocean stratification and its diurnal evolution and in transitional variability associated with local diurnal convection. And the third one is investigate the interaction between land, atmospheric, and oceanic process. And we also have another activities that have been done since 2017, the Weather and Climate Science for Service Partnership. This is a collaboration within the Southeast Asia countries with the funding from Newton Fund and supported by UK Met Office. From this project, Malaysia, Philippines, UK, and Indonesia want to engage, especially to improve the understanding of the impact of large-scale atmospheric processes, assess, develop, and improve convective scale models, improve the process which translate weather forecast model into advice. It's what we call like impact-based forecast, and we want to ensure the improvements made to weather forecast meet the needs of the users. We have 3 work packages here. Work package 1, understanding and evaluation of a large process. Work package 2, focus on regional scale science. And work package 3, focus to improve and understand the needs of high impact weather advice. There are several activities that has been done through this project. This is what we have done in our work package 1. Several meetings also have been conducted last year, and through this year we have several virtual meetings also. This is what we have in work package 2, and we hope that we will continue this collaboration with several issues that we need to cover. And this is several papers that has been published through this activity. And then there will be activities that will come into force in, we do hope it will be start in this year, but because of the pandemic also, it will be delayed to next year. The name of the activities is Measuring and Modeling the Indonesian Throughput International Experiment, MINTI. This is a collaboration among international scientists from USA and also from Australia and China. So from these activities, we will collect ocean data over Indonesia through flow zone, and we will have simultaneous internal storage. Yeah, an array of profiling flows. And this is the another program that we will that we have already conducted since 2016. What we call the Indonesia Prima, Indonesia Program Initiative on Maritime.
In the
Recording
near
in
future,
progress.
ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first President of the Republic of Indonesia, B.J. Habibie as the third.
Recording in progress.
Sorry, this is the second time with the trouble with the technical trouble. Okay, I think you can continue your presentation. Please unmute your speaker, Ibu Deli. So it is still mute.
Sorry.
Thank you.
sorry. Yeah, we want to conduct a weather, ocean, and air quality observation over Indian Ocean, and want to utilize the ocean observation data and maintenance of particular Rama buoys in Indian Ocean. And we, through this program, we need to, want to improve our capacity building, especially in ocean instrumentation and data analysis. This is the activities. It's as I already mentioned, is we go to the Indian Ocean to collect the marine meteorology observation data and to maintain the buoy, Parama buoy, and to validate our forecast system. And the last one that I want to share that right now, because we do understand that our weather and climate is not just affected by global and regional phenomena, but we need to consider our local information, our local data. So because we want to have a more accurate information and want to have a more accurate prediction. So we develop this model based on the the wolf with assimilated with our own data. So we assimilated with the radar, upper air sounding, synoptic data, and automatic weather station data throughout Indonesia. And the current weather prediction is arranged according to the hardware capability that we have. 3 days forecast with a 9 kilometer spatial resolution for Indonesia and 3 kilometer for Java Island. So in conclusion, I want to highlight that the goal of our research actually want to improve the our prediction, our weather prediction and climate, our weather forecasting and climate prediction. But we do understand and realize that we need partnership. We cannot do alone all the things, but that's why we collaborate with not just with our national agency or national parties, but also international, and also need support from the university and also from the private sector. That's the one that I need to highlight. So I think this is the end of my presentation. Thank you very much.
Thank you very much, Pak Ibu Nelly. So I open the Q&A session. Is there any question from the participant? Okay, Pak Hansan, you already raised your hand. I give you a chance. Give the chance for you.
Thank you. Thank you for Chairman, and thank you for very nice presentation. Yep. Has important responsibility to measure and observation on the sea and also weather and many things. Yeah, and actually my question is, when we want to find some observe the data in the ocean, it is very hard to get it. Yeah, I mean, so there is many projects and also many buoys. Sometimes there is buoy and also something, but actually we cannot secure that, we cannot approach the data and find and get the data. So so in your presentation there are also many projects and many observation equipment and buoys. So the data is already stored in the BNKG for, and so my question is, my question is, can we access that data, and can we use the data for research purpose? That is my question.
Thank you very much, Mr. Pak Hansan. Actually, the one that I showed to you, it will be done maybe not we don't have any right now, but we will have many I think from these years, because like I show you that we will continue to improve our ocean observation through the marine meteorological system, strengthening of marine meteorological system. It will be conducted. I think the buoy and all the things will be deployed in next year. So we will have and we plan to have all the data through the GTS. So because we do not want to keep the data for ourselves, because we do realize that that maybe many researchers, especially international researcher, want to have the data from Indonesia. But for the Rama buoy data, I think it's already on GTS. You can access it. And for other data that usually BMKG, for BMKG, right now we don't have any data from buoy, because we have not deployed it yet right now, but we plan to deploy it starting from this year actually. But what we have right now just a few little data on the coastal area, of course, but it is not equipped with the oceanographic instrument, but focus on the atmospheric equipment and measurement that done in the coastal area. But of course, I think like from the data that deploy in YMC project, you need to be the member of the YMC, so we can you can use the data because there are like an agreement between us in the consortium, and if I can say that it's consortium, I think. Thank you.
Thank you, Ibu Nelly. And Hansan, do you have any question, or is the question, the answer is already clear for you?
It's yeah, enough. But can I have one question or comment?
Of course.
Yeah. So maybe you already see my presentation. We also have a joint research topic that was operational ocean forecasting system, and also the other thing also using numerical model for ocean. And we fears Indonesia government has a good plan to secure the observation network. Also we want to support it, and we also contribute to it. So for this year, actually we have a plan to install the tide station with the weather or AWS in Cirebon. So maybe maybe we can have additional meeting about that. And also we already set Cirebon area's numerical model for ocean forecasting, so we can also collaborate about that. So I hope we can continue our cooperation and strengthen more. That's my comment. And thank you.
Okay, thank you. I think I propose to have a special discussion on this, a special meeting maybe in the very near future, of course. Thank you.
Thank you.
I will give you my contacts detail through Bu Yvonne.
Thank you, Bu Nelly. So because I also belong to MTCRC now. Thank you. I think is there any a suggestion, comment, or a question again from the participant? Because we have still time, maybe for 5 to 10 minutes. So, Pak Erka, do you have some question?
It's okay, well, thank you so much.
Thank you. Okay. If not, so I think we have already watched and also hear the presentation of 3 speakers, and I'm happy as the moderator because I see that after this session there is already talking about the collaboration between Korea and Menko Marves, and also between BMKG. I think this is the goal of the meeting. This is the goal of this session. Thank you for this. Thank you, Bu Nelly, for your nice presentation. And I think we have also got a lot of more information that I never heard about that. But then I think what we have done in Puslitbang BMK should be very important, very useful for our country. Thank you. And before we finish this session, please we will take a photo session. Please, would you like to open your video? Bapak Ibu bisa membuka videonya. Kami akan mengambil foto session. foto pada sesi ini. I see that still lot of camera layarnya masih monitor. Silahkan Bapak Ibu. Kita silahkan membuka videonya supaya nanti kita bisa mendapatkan gambar yang lebih baik. Saya masih menunggu mungkin dalam 1 menit 2 menit ke depan Bapak Ibu yang masih mungkin tidak punya kegiatan atau bisa membuka kameranya untuk kita foto bersama. Okay. Now I will take in 2 shot and okay, 1, 2, 3, and this is the second. Thank you. Okay, so this is our final discussion, and then after this you can go to the main room. What the main room will start the session on 3:30 p.m. You have still enough time, I think 15 minutes to do something and or to eat something or to have drink
virtual
something.
coffee.
Yes. Break time, so you can go to the maybe your room or your office and then do something, and then we will meet at 3:30 p.m. and please don't leave the session because we will closing the session, but before that we will announce the best presenter and also the best participant. So hopefully that you're lucky to get the nomination of this best presentation and also best presenter and participant. So thank you for all the speakers, Pak Kus, Dr. Hansan, and also Ibu Nelly, and also the participant who joined this from the beginning until the end of the session. Hopefully that you have got you get a lot of information, insight, and also maybe data, information, and etc. And this MSAT is a 2 years biannual international conference meeting, and then we will meet you again for the next 2 years. Maybe we do not yet decide where, but we hope that you can still be part of this the 4th MSAT. Thank you very much for your presentation and also for your attendance for this session. Looking forward for go to the main room. Terima kasih Bapak Ibu untuk kehadirannya.
Terima kasih.
Sama-sama
terima kasih. 감사합니다.
Kamsahamnida.
Selamat sore Bu Kiara, Ibu Kiara.
Ya, terima kasih Pak Hansan.
Ya,
Halo Bu Yaya.
Ya, makasih.
Ya, jadi ketemu di Pangandaran kita.
Iya, padahal.
Ayo, kapan lah?
Ya?
Itu Pak Agus set ini.
Next time.
Semuanya ya. Congratulations.
Ya, terima kasih semuanya. Terima kasih buat Bapak Ibu guru, terima kasih untuk hadir. Semoga ilmunya manfaat dan bisa dibagikan kepada para siswa mungkin untuk silahkan kita bisa meninggalkan dan kembali ke main room.